Hello everyone, welcome to my class. In previous classes we have already discussed about the heat energy and its various properties. Today we will start the class with thermal equilibrium. Okay. Thermal equilibrium. Students, we have discussed about heat. What is heat? It is nothing but a form of energy. Okay? Form of energy. Form of energy. But what happens? It transits from higher temperature to low temperature. Okay. So what is temperature? Temperature. Temperature, it is the degree of hotness or coldness. Okay. Hotness and coldness. Fine. So these things we have already discussed in our previous classes. Students, we know that a body can be hotter or cooler. It depends upon temperature. Okay. So thermal equilibrium. Equilibrium comes from the base word equal. Okay. So equal temperature. If two bodies, they have same level of hotness or coldness, that means temperature, then we call that state as thermal equilibrium. We will discuss some example and try to understand the concept. Okay? Students, many times we go through the state of thermal equilibrium in our day-to-day life. See, whenever we don't feel hotness or coldness, then our body is in thermal equilibrium with the atmosphere. Same way, when we touch the objects, those are placed in room, they are also always at thermal equilibrium with the atmosphere. When we apply heat energy to an object, it gets hotter. Otherwise, it remains at the same temperature, that is of the atmosphere. So we don't feel any object hotter in a room. Okay. So these all are the state of thermal equilibrium. We know that heat energy transfers from higher temperature to low temperature. So whenever two bodies are in contact, what happens? If a body has high temperature and another body, it is having lower temperature than the first body. So heat energy starts the transition from higher temperature to lower temperature till the time both the bodies in contact are at a same temperature level. Okay. Let us have a look at it. Okay. Students, as you can see, there are two objects having two different colors, brown and black, and one is at 90 degrees Celsius and another is 10 degrees Celsius. So what happens over here, the heat starts its transit from the brown bar to the black bar till the time both the bars have an equal temperature of 50 degrees Celsius, and that is the state of thermal equilibrium. Okay. Students, let us now discuss an activity and try to understand how heat transfers. Okay. See, we have two containers. In one container we have hot water and in another container we have cold water. We have put two laboratory thermometers inside the containers. Okay. So what's happening? When we keep the thermometer, the hot water, it gives us the temperature 80 degrees Celsius and the cold water gives us the temperature 15 degrees Celsius. After 5 to 10 minutes, if you take the reading of both the thermometers, you will find an amazing change. What is that? The thermometer inside the hot water will show a reading that is higher than 80 degrees Celsius, that is suppose 95 degrees Celsius. And the thermometer inside the cold water will show a reading that is lower than 50 degrees Celsius, that is suppose 30 degrees Celsius. What is happening over here? The mercury inside the thermometer is at a certain level, okay, which is less than the temperature that the hot water carries. So what is happening? The temperature in the hot water, it transfers itself into the mercury that is inside the thermometer. That's why the level of mercury rises to 95 degree. The 15 degree rise in the mercury level is because of the heat transfer from hot water to mercury. In the same way, inside the cold water, the level of mercury was at 40 degrees Celsius initially, which falls down to 30 degrees Celsius. In this case, mercury has higher temperature than the cold water. That's why the heat transfers itself from higher temperature to lower temperature. That's why heat transfers itself from the higher temperature level to lower temperature level, and the temperature falls to 30 degrees Celsius. Okay, in this way, heat always transfers from higher temperature area to lower temperature area. Okay. Students, in the last activity, we discussed that how heat transfers itself from higher temperature area to low temperature area. See, the level of mercury, it rises or falls up to a certain level. After that, it doesn't rise or fall. Why does it so? Because now the temperature of mercury is equal to that of the hot water or the cold water inside which it is kept. So the temperature of two bodies, that is mercury and water, they are at a similar level or exactly same level. This state of these two bodies are called thermal equilibrium, where they have same temperature and the temperature doesn't change. Okay, so if there are two bodies, suppose A and B, okay, and they are in contact with each other, fine, they are in contact, so they will be called at thermal equilibrium if they have equal temperature level. So suppose there are three bodies A, B and C. Now A and C are at thermal equilibrium, same way B and C are also at thermal equilibrium. That means they are maintaining equal temperature. Then we can also say that A and B are at thermal equilibrium. Why? Because now if A is equal to C and B is equal to C, that implies A is equal to B. Okay, so they are also at thermal equilibrium. So we can have multiple objects at thermal equilibrium at the same time. It doesn't matter they are in contact or not. If the bodies are maintaining same level of temperature, then we can say that these bodies are at thermal equilibrium. In this case, A and C are in contact physically. Same way, B and C are in contact physically. But A and B are not in contact physically. But they are maintaining thermal equilibrium, as we have already discussed. So we can say that they are at thermal contact. Thermally, they are in contact with each other, though they are not in contact with each other physically. Okay? Students, let us now discuss the units that we actually use to measure heat and temperature. Okay, so SI unit for heat. SI unit is joule. Okay, and CGS unit is calorie. So 1 calorie is equal to 4.186 joules. Fine, you need to remember this relationship. So how can we define calorie? 1 calorie can be defined as the amount of heat energy required to raise the temperature of water by 1 degree Celsius. Okay, so this is just the definition you need to remember. And what about temperature? Temperature, its units are degree Celsius, degree Fahrenheit and Kelvin, which is written as capital K. SI unit is Kelvin. Okay, SI unit of temperature is Kelvin. So what is the relationship between degree Celsius and Kelvin? Kelvin is nothing but T degree Celsius plus 273. You need to remember this, which will help you to convert any temperature in degree Celsius into Kelvin. Okay? Students, one more thing you need to remember is that whatever temperature we measure in Kelvin is called absolute temperature. You just need to keep all these things in mind. Okay? Students, let us now discuss about temperature and kinetic energy. What is kinetic energy? Kinetic energy is the energy possessed by a body in motion. Okay? So, relationship, how temperature is generating motion or how is it affecting the motion. Okay, this is the main thing to discuss. See, if you have two bowls, one bowl contains hot water and another bowl contains cold water, and if we put grains of food color in each bowl, you can observe the jiggling of the food particles inside the water. What does it mean? Jiggling comes from the word jiggle. Okay, that means random motion. Random motion. Okay, you can clearly observe that the jiggling inside the hot water is more than that of cold water. That means the food particles inside the hot water, they possess more average kinetic energy than the food particles inside the cold water. From this, we can come to a conclusion that hot bodies possess more kinetic energy than cold bodies. And how come we come to know about this? Or what helps us to come to this conclusion? That is your temperature. Because temperature makes us know which is hotter and which is colder. That's why we distinguish between hot water and cold water. We can also say that temperature is the indicator of average kinetic energy of a body. And then the relationship between kinetic energy and temperature, that is, kinetic energy is directly proportional to temperature. As we have already discussed that kinetic energy is more when the body is hotter. That means hotter means more temperature. So more the temperature, more will be the kinetic energy of the particles of the body. That's why kinetic energy is directly proportional to temperature. Okay? Students, let us now discuss about the relationship between heat energy, temperature and kinetic energy of the particles. Okay? For that we are going to discuss this activity. You need to take some water inside a container and boil it up to a temperature 60 degrees Celsius. Okay? You need to cover it with a lid and make two holes. Okay? You need to pour coconut oil over water gently. After that, what you need to do? You need to put two thermometers at two different levels through two holes in the lid. You need to keep it in mind that one of the thermometer goes inside the coconut oil. It should not touch the level of water. And the other thermometer should go inside water. Now, you can clearly observe that the reading of mercury in the thermometer which is inside the coconut oil is increasing and level of mercury of the thermometer which is kept inside the water is now decreasing. Why does it happen actually? Because now as the level of mercury is increasing in this thermometer, that means the temperature of the coconut oil is increasing, and the level of mercury is decreasing in this thermometer, that means the temperature of hot water is now decreasing. Why does it happen? Because hot water was at 60 degrees Celsius temperature previously and coconut oil has a temperature lower than the hot water. Now the heat transfer happens from higher temperature area to lower temperature area, thereby shifting the temperature as well. That's why the temperature of the coconut oil is increasing and that of the hot water is decreasing. And it affects the reading of the mercury in both the thermometers, which can be visible clearly. So the particles inside the hot water, they are having more average kinetic energy than the particles inside the coconut oil, and the energy transfer happens over here, thereby transferring the heat, thereby changing the temperature of coconut oil and hot water. So what we can also observe that coconut oil is gaining kinetic energy as it is gaining heat energy from hot water, and hot water is losing kinetic energy because it is transferring heat energy to coconut oil. Okay, hope you understand. Students, today we have discussed about heat, temperature, transfer of heat energy and thermal equilibrium. From our discussion, we can come to a conclusion that temperature is the direction of flow of energy or flow of heat energy, and heat is the energy which flows. Okay, I hope you have understood everything clearly. If not, please watch the video again, go through the content that is given in your book, and I am sure that you will be able to understand everything clearly. So keep revising, keep practicing, and most importantly, keep smiling.